Kia ora team, this is Mr. Dharma, and today I want to talk to you about areas between two curves. So let's quickly draw two functions. The first function can be this, and this can be my next function. Okay, if I want the area between these two functions, this part here, the first thing I've got to do is I've got to identify this point and this point, which are the intersections of the two curves. And then I've got to identify which function is on top. So let's write this function out. So first off, let's say g of x is equal to 2x plus 7, and f of x is equal to x squared minus 8. Okay. First, what I've got to do is I've got to find out where these two graphs intersect. So the easiest way to do this is to set these equal to each other. If I have g of x equals f of x and solve, we can find the two roots. So 2x plus 7 equals x squared minus 8. And so I move everything to one side, I get x squared minus 2x minus 15. Factorize, I get x plus 3, x minus 5. And so the two roots are x is equal to negative 3 and x is equal to 5. Alright, so based on that, I know that this is negative 3 and this is at 5. Right, I want to now find the area between these 2 points. So I'm going to set up a definite integral from negative 3 to 5. And here's all I need to do. All I need to do is I need to do the area, whichever function's on top, so g of x, minus whichever function is on the bottom, which is f of x, and put that in brackets, dx. And that works. So if I wanted to work this out, I'd just have to go g of x minus f of x, integrate definitely between these two, and I will get my answer. Okay, I'm going to show you a visualization for this really soon. But let's try this out. So, integral negative 3 to 5 of 2x plus 7 minus x squared minus 8, making sure I use brackets. And so if I simplified, I get the negative 3 to 5 of 2x plus 15 minus x squared dx. And so if I integrate, I get x squared plus 15x minus x cubed on 3 from negative 3 to 5. I'm not going to do more. I'm going to let you substitute and work these out. But the point is, I will work out that area between them if I just use this formula. The limits of where they intersect, and the one that's on top minus the one that's on bottom. What I'm going to do is I'm going to show you a visualization of this, because I think that will really, really help. So, imagine if I drew my two functions. This is g of x and this is f of x, and I want this area between them. Okay, and this function, the difference function that I had, well, it actually looks like a quadratic itself. It was the negative x squared plus 2x plus 15 function. That's the equation of this one. And that's the same as integrating from negative 3 to 5 of this. And the reason is, this green area is the same as the area under that black curve. And we can have a look by deforming. The area is the same. And so the area between those two curves is the same as the area underneath the function that you get for the difference. And that's what's really, really important. All you need to do now is do the substitution. But this function in here is that black curve that we got. And we integrate from negative 3 to 5, and that will still be the area. Okay, so for integrating between two functions, you don't need to worry about whether there's area that's positive or negative. You just need to make sure that the top function always minuses the bottom function. If you've got overlaps, like this, then your function might be above in one point and below in one point, at which point you're going to have to split your integral into two parts, where in the first part you work out f of x minus g of x, and the second part you work out g of x minus f of x, because you need to make sure that the function that's on top is the one you're integrating. And so you have your limits, 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 and so you'll do this integral between these two limits and this integral between these two limits. Thank you.